So in this video again, we'll be looking at proof by induction and inequalities question. So to remind you of the major points of the inequalities questions, I would really highly recommend actually that you pause the video and take down this green box and then watch the rest of the video and try and identify the key points of the question. Okay, so the question stated that n factorial is greater than 2 to the power of n, and we actually have an initial condition. So after watching the last video and the last 3 videos, I suppose, on proof by induction, we should realize that step 1, prove true for the smallest allowable n. Smallest allowable n is going to be n equals to 4. So important to identify that straight away. Also, key point about this, n factorial. Well, what is n factorial? That's n multiplied by n minus 1 multiplied by n minus 2, and it keeps going all the way until you get to the number 1. Might be a little bit easier to identify with 7. That's 7 by 6 by 5 by 1. And a really important note is that 7 factorial is the same as 7 multiplied by, well, what is 6 by 5 by 4 by 3 by 2 by 1? That could also be written as 6 factorial. So 7 factorial is the same as 7 by 6 factorial, and we'll come to that again in a second. Okay, so step 1, same old. We're proving true for the lowest allowable n. Again, here I'm just talking through what factorial is. 7 factorial is 7 by 6 by 5 by 4 by 3 by 2 by 1. Generally all you need to know, but for this style of question we need one tiny bit more, which is what I just proved up above in the purple. Now this bit is really important, what k plus 1 factorial is. K plus 1 is every number before it multiplied together until you get to 1. So what's before k plus 1? K. What's before k? K minus 1. What's before k minus 2? So on. And then it can be written as k plus 1 by k factorial. You might recognize that that's probably going to be useful in step 3. Okay, so step 1, proving true for the smallest allowable n. Smallest allowable n has to be greater than or equal to 4, and n has to be an element of the natural numbers. So we're going to prove true for the smallest allowable n, which is 4 in this case. So it's 4 factorial, and you can type that into your calculator. If you have a Casio calculator, the factorial button is located below the mode button. It's in yellow, so you're going to have to hit shift. You might see this button on your calculator, and just above it in yellow is the factorial, so x factorial. So you'd hit 7 and then you'd hit that button there. Okay, so next step, assume true for n is equal to k. Sub in n equals to k. So subbing in k, we're assuming, as far as I'm concerned, this is true. We're going to come back to this step then. So that's really important. That we're going to come back to this and modify the left-hand side to make it look like the left-hand side of step 3. So step 3, prove true for n is equal to k plus 1. Subbing in k plus 1, so k plus 1 factorial. Power over here is 2 to the k plus 1. What did we identify earlier about this? That it's the same as k plus 1 by k minus 1 by k minus 2 by k minus 3 all the way down. Or also that k plus 1 factorial is k plus 1 by k factorial. And that's going to be useful as well. So this is our goal that we want to prove. This is what we want to prove. So calling those A and C. I want to prove that A is greater than C. So the trick, go back to step 2. So what would I have to do to the left-hand side here to make it look like that left-hand side? I would need to multiply it by k plus 1. But I cannot just multiply the left-hand side of step 2 by k plus 1. I must multiply the left-hand side and the right-hand side by k plus 1. So what must you do to step 2, k factorial is greater than 2 to the k, to make it look like our goal? So the left-hand side, as I said, multiply both sides by k plus 1. And this here is now our A and our B. And as far as I'm concerned, this is true, this assumption. So what I really need to go and prove, I know, well, I think I've it written down. So what are we identifying? Our A and B from step 3, our A and B from the modified step 2, our A and C from step 3, step 3, step 2. I know A is greater than B. I want to show A is greater than C. If I can go and show that B is greater than C, then A must also be greater than C. Okay, so how do I go about doing that? So I'm taking B here, the yellow on the left, and the blue on the right. I want to show that this is true. How do I actively go and show that? What can I do from the first line here going down to the second line? Well, what have I done over here was use page 21 of the log tables to try and simplify that. I can then divide both sides by 2 to the power of k. Now, I'm very happy to do that because I've identified over here that 2 to the power of anything is greater than 0. Just making sure with inequalities we're very conscious of multiplying and dividing by a minus number. So just identify that we're not dividing by a minus number. 2 to the power of minus 1. If you put that into your calculator, you'll get a half. 2 to the power of 1, put that into the calculator, you'll get 1. 2 to the power of 1 is 2, not 2 to, not 1. 2 to the power of 1 is 2. 2 to the power of 0 is 1. And they are all positive numbers. 2 to the power of anything is going to be positive. So I'm allowed to actually divide by 2 to the k because I know this is positive. Whereas if it were negative, I would have to flip the direction of the inequality sign. So I'm left with k plus 1 is greater than 2. K plus 1 is greater than 1. Well, is that true? Is k greater than 1? Well, k follows the same rules as n did, and we said n was greater than or equal to 4, and n is an element of the natural numbers. So if n follows, or if k follows the same rules as n, then k must be greater than or equal to 4 also, and k must be an element of the natural numbers. So this is true. K is greater than 4. So is k greater than 1? Yes, it is greater than 1. So true for n is equal to k plus 1, assuming true for n is equal to k, as n is greater than or equal to 4, and k is greater than or equal to 4. And then restate the question that was above. N to the power, or n factorial is greater than 2 to the power of n for all n greater than 4. N is an element of the natural numbers. And I've written it down again. I've written it down twice, but that's not really needed anyways. Hopefully the video helps you anyways.